self-similar fragments. Okay, and what I'm saying here is, again, referring back to Ken's shoulders, they can sit in the metal indefinitely, but then if you overexcite them in a way, they can blow up. And this is going to be very important to the technology and the testimony from the technology, which I am going to be concluding and discussing with respect to this vibrations in the steam room. These traveling subfragments can disrupt matter as they travel. And this is the action of strange radiation. We're going to show a couple of examples of that. I did a lot of the work in the previous presentation on that. So is this a unique finding? The unique finding of Stanislav Adamenko and the team of scientists working there by maybe as much as 6 years in the former Soviet isotopic factory here in Ukraine? No, it is not. This is in Matsumoto's paper that was published in Fusion Technology in September 1992. And this was in heavy water, deuterium oxide. And he's got these black spots here. And he's saying figure 1 shows spherically symmetrical traces. So you're just seeing a cross section here, but it's actually spherical with different diameters. These traces were recorded inside the nuclear emulsions so that they can easily be separated from the patches that are produced on the surface of the emulsions during the film developing process. All of the traces consist of 2 regions. The inner region is almost completely black, but the outer black dots are radiatively distributed. This suggests that some radiation and the particles might have come out from the center region. Okay, so you're looking at a slice of a structure that's observed inside emulsions. Now, what do I mean by nuclear emulsions? Takaaki Matsumoto, Dr. Matsumoto, was a nuclear radiation monitoring and detection expert, and he was an expert in nuclear, and so he knew what he was looking at. He knew when something was a processing error, film processing error, because sometimes when you develop film, you get these little marks and imperfections on the surface of the film. So that's what he's referring to there. He's saying that this is inside the polymer of the emulsion. Okay. Another one here from September 1992, but in a 1993 paper that I've just put here. Figure 7, a tiny black hole was expected to be generated from the collapse of multiple neutrons. Collapse of multiple neutrons. This is something similar to what is later being discussed in a 2003 paper with Vladimir Vysotskii about the work of Stanislav Adamenko et al. And might be used from massive nuclei as the host metal and the electrolyte. In the case of Matsumoto, he was doing explosive cold fusion using electrolysis. So he had a water type, in this case it was D2O, heavy water, some form of electrolyte, maybe potassium carbonate or potassium hydroxide or something, or sodium hydroxide, and he was electrolyzing that, and sometimes he was causing an explosion. And so he was creating a high short duration transient event. So it's quite similar, but obviously with a much more simple technology to that used at Proton 21 labs, and observing something similar produced like this. And you can see it really, it's all speckling. You have to imagine that this is a spherical object. So if you cut the emulsion, in half, you would see this in the middle of the emulsion, as well as seeing something almost identical from the top with this kind of radiation coming out here. It says, the evaporation of tiny black holes has been successfully observed in heavy water. Figure 7a, this one here, shows Hawking radiation and the evaporation of tiny black hole, which is similar to the traces observed in the previous experiment with heavy water. Now, what does he mean by Hawking radiation? Hawking, before he died, I think he had something to say about whether he still believed in the event horizon, whatever. What we can see from the video captures from the device, this secondary ion mass spectrometry of Adamenko, is that something was going in, something was being assembled and progressively emitted, and it was energetic particles. And so at the very least, they were observing 433, but the device is not necessarily set up to detect mesons coming out, muons coming out, high-speed electrons, high-speed photons and such. It's there to detect these ions coming out. So it's working in a different way. So he could be right in saying that the material is torn up shoulders. He's saying when it absorbs matter, the energy is released in the form of UV, extreme UV, and soft X-rays up to 2 kilo electron volts in the condensation process, and you can have 1 ion captured per 100,000 electrons. Okay, so one would imagine there's a lot of electrons in here. In the case of Matsumoto, though, he was saying that you are producing what are called itons. Now, what is an iton? An iton is a positron and an electron bound together with a neutrino. Now, if you have a positron and an electron bound together, you have positronium, okay, which is a kind of structure itself. And positronium is bound together. What's it bound together with? I don't know. But in the case of Matsumoto, he's saying a positron and an electron are bound together with this neutrino. And if you can imagine an electron cluster collapsing, apparently, according to Matsumoto's book, which you can get from remoteview.icu, we've got over half of that published now, so you can download it with all the papers in there and his steps to discovery of electronuclear collapse. When this thing is collapsed, it polarizes. Let's say you've just got a proton, the nucleus of protium, a monatomic hydrogen nucleus. As it's compressing the nucleus, it polarizes the proton such that you get an emission of a positron and you get an emission of a neutrino. And so then, if you take your monatomic hydrogen, which is normally a proton and an electron, and this process goes forward, you then have a neutron in the center, and you have a positron, an electron, and a neutrino. And the positron and the electron and the neutrino become into a bound state, and that forms the iton, which is a neutral particle, okay? And a neutron in the core, which is also neutral. So you have a structure at the very basic level which is able to pass into matter and transmute it. Now, any other nucleus in the periodic table has more neutrons and protons, and in fact, up to calcium 40, like calcium 40 is like 20 neutrons, 20 protons. It's dec alpha. It's half and half. But even then, you've got 20 electrons, 20 protons, and 20 neutrons. The 20 protons can produce 20 positrons and 20 neutrinos. You end up with these 20 forms a cluster around your 40 neutrons in the core. So any neutrons stay a neutron, and any protons part in producing the itons, and the itons form the clusters. And it's interesting because Adamenko observed that in some of their experiments, they got emissions of heavy nuclei with 5,000 to 7,000 ANU emitted. 5,000 ANU, and somehow these things are flying out of their experiments and remaining stable long enough for them to interact with other matter. And if you've got 7,000 neutrons interacting with other matter, well, it's going to cause a lot of transmutation, isn't it? If you get electronuclear collapse, where the itonic shell interacts with other matter, is able to collapse further. Now, the itonic mesh, and he said that this is detailed is, and he agreed that what he was doing in 2001, he agreed that essentially they were talking about the same thing, exotic vacuum objects and itonic clusters. But Ken Shoulders was not a theoretician. He said often that he's not into theory. He just described what he saw and could repeat what he saw every day of the week. Okay, whereas is which is important in science, one might like to say. Okay, so now whether Matsumoto is correct, I don't know, but certainly what he's saying produces something that's neutral and can do the things that were observed by Stanislav Adamenko. Now, Matsumoto didn't stop there. In a paper in 1993, he published this. Figures 7b through 7f, these ones here, shows the typical feature of the black hole. The conic shape material seem to spout energetically from the bottom of the cone, right? So he has these cones here, and you get these structures coming out. And whether this is, he said that you had a white hole and a black hole, and this did this material organization. So here, this is a white hole and a black hole. And so you'll actually, rather than looking at top down, these slightly more, these are exploded black holes or something like that. It's in this paper from 1993. But the interesting thing for me is that this particular structure, he's often saying that it synthesizes a lot of carbon, and I've discussed in many presentations why carbon comes out. It's because it's triple alpha. Alpha is the most stable sort of grouping of nucleons, and many synthesized elements become alpha conjugate nuclei. And if you make alpha, it floats away. If you make beryllium-8, it decays to 2,4 alpha, it flows away, and it's helium. So the first stable element that comes out of these systems when it's doing electronuclear collapse and electronuclear regeneration is carbon. And so you see these carbon marks on here. Now, this is on the fracture sample from John Hutchison in a presentation called Hutchison Effect Magic Incarnate. In this YouTube link, you can go and see a big discussion about this in relation to Matsumoto. But here's one of these structures in 3 dimensions. So this is caught inside an emulsion or on the surface of an emulsion. This is in 3 dimensions. And the interesting thing is, and I've got the whole thing, and it's almost identical shape. And funnily enough, the actual areas here are almost identical in terms of their positioning. So there must be something very regular in what happened when these things blow up here are diamond. And the strands along the edges are magnesium. And the interesting thing about magnesium is it's double carbon. Okay? So out of our black hole, we have carbon predominantly coming and double carbon on the ridges. Okay? So, and the thing is that these structures produce solitons. These are like donuts of 2 different types. A predominantly north pseudomagnetic monopole and a south magnetic monopole. And in the same presentation, they can produce these flux loops. And so we'll have a north or a south here and a north or a south here, and material is swept between the 2. And at the point of the boundary where they meet, it's like a phallico-soliton, like you have in a swimming pool. There's kind of some disturbance. And things bleed out, and when it's out in here, it's absolutely, you have to go and look at that presentation. It's a much more complicated discussion. But here we have what I believe is the pit created by a black hole that would be in this core here. When I say a black hole, it's a thing it has a vortical structure that goes into it in a pole, and it has a space which it's kind of almost quantum locked into the paramagnetic aluminium. And the magnesium, actually, this has magnesium and aluminium in it, probably. And so you have something that's in this area here, and both magnesium and aluminium are paramagnetic. So it can bind to those nucleus, these structures. So are there other ways of doing this? Well, the surest way to create these structures and the quickest way to kill yourself if you want to get loaded up with transported ions that blow up inside your body is to use a hydroxide. And this is the one of Alexander Shishkin and his colleagues at the Science City north of Moscow in Russia. And it's basically an industrial electric motor here. And then inside this structure, it has a series of keyways that are radially arranged, and so you get intense cavitation in there. And this, in a presentation which I'm going to go into here, which is a new type of penetrating radiation. He talks about the other ways that we've created these magnetic monopole-like structures. So I'm going to drop out of this now, and I'm going to go to that presentation for you to look at. So this is the presentation. You can go and look at it on our YouTube channel. You can go and see the original Russian presentation and my translation of it. But this is a new type of penetrating radiation, Alexander Shishkin, and this is from October 2018. Okay, so he talks about the fact that this type of high energetic radiation, which is often 120 kiloelectron volts, sort of seemingly when it blows up, and it's much more energetic than characteristic X-rays, were observed by Charles Glover Barkla in the 1910s, and after he won the Nobel Prize in 1970. For discovery of characteristic X-rays, he literally spent the rest of his life trying to work out J-rays. When it came to post 1989, many people in the cold fusion field observed these emissions of 120 kiloelectron volts. And in this interview here from 1996 with one Martin Fleischmann, that our project is named after, he talks about these not soft X-rays. If you have got high energy X-rays coming out, and this goes back to Stanislav's back, lots of people say, well, it's soft X-rays, but soft X-rays would never get out of the cells. And so that had to be blah, blah, blah. So essentially, are these coherent X-rays? What do they do? Okay, it is coherent matter, it is these structures. But interestingly, in this with Christian infinite energy, the only question talking about anti-gravity is the only time that it goes Fleischmann, and there's a ... between the two things. And he said they were researching 4 different things at the time that they were doing cold fusion. One was cold fusion, one was the behavior of electrons in metals, including room temperature superconductivity, and another one was blah, 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 we're not going to mention that. And then there was this whole discussion about anti-gravity, which they kind of edited out, it would seem. Anyway, if I mentioned this maybe before in the previous presentation, that Simon E. Schnoll published this book, which you can get. It's from studying papers from 1951 to 2008, and it's on physical factors in random processes. And in the conclusion of this book, which, like I say, you can download for free, it's in conclusion, Simon Schnoll argues that all random processes in chemistry, biophysics, physics, including fluctuation of the decay of rates of radioactive elements measured at the same time in the same place, are strictly correlated with each other. Based on this analysis, Schnoll, as well as other researchers, for example, Parkhomov, Baurov, etc., concluded that there exists a certain cosmophysical factor, agent, which actively influences virtually all processes occurring on the Earth and in space. And this here is the relic neutrino flux, which was referred to by Tesla in his 1880s, 1890s work as these infinitesimally small corpuscles that come from the cosmos rather than coming from the star. Anyway, Shishkin calls it magnetotoroelectrical radiation, and he believes that this is the agent. And when he ran these experiments with that cavitator I showed you earlier, he observed these, what they call birdies. And if you can imagine a mushroom sliced in half, this is the structure. And I talked about this in my previous presentation. And when some guy analyzed these photographic film plates, he said, well, have you got an iron bombarder? What's going on? Because they saw these pits underneath the birdies in the film. And these microcraters and these birdies, they were able to create in these different ways DG from revolving bodies made of various materials, titanium, cadmium, etc. Now, why is this important? This is important because of people using spinning material to create anti-gravity. I'm saying that these things are relating to shielding of gravity or removing the effect of gravity on other bodies. I'm saying you can aggregate them into large self-similar macro clusters. They will affect all kinds of things that I gave in my previous presentation, like light, like radioactive decay, like the crystallization of metals. Plus, they will also cause forces or a perceived force. And I talked about the work of Xu Wenju from 1988, 1999, and of Maurice Allais, that's on the NASA's website from, I think, 1954, where they observed the focal pendulum, in the case of the latter author, changing during three-body alignments. And in the case of Xu Wenju, he saw a sideways movement in a metal plate during a three-body alignment. And this, I believe, is the pressure form of gravity, and the pressure is created by the superfluid, superconducting condensate that pervades the entire universe, which is relic neutrinos. Anyway, so a spinning body. So you might have another, I think the Tuchanov device is a spinning body. Many people refer to spinning bodies. These structures come out of things that you spin quickly. And I've got permission now to translate the work of Alexander Shishkin into English, and I will be putting that in the next month or two onto remoteview.icu if you want to follow that work. But he took things as these cones of metals and spanned them at something like 5,000 RPM, and this strange radiation is emitted. Okay. From materials irradiated with gamma radiation. So just shooting gamma radiation at something is able to produce these magnetic monopole-like structures. John Hutchison used some uranite in his experiments. He always had this big lump of uranite, and so that will have cesium-137, one example of a gamma emitter, and that will emit gamma rays. So he had seed structures in order to create these things that could produce his effect. From gamma sources specifically, rather than just from a gamma radiation. So you can create gamma radiation by taking a high-speed electron and passing it through a combinable target, or you can create it from actual gamma sources, from gamma. So cobalt-60 here and 137 cesium. So you would have got these sort of things from Fukushima in abundance. And so the idea that you would have these magnetic monopoles binding to the oxygen, producing the weird glow above Chernobyl, and some weird events Fukushima is not surprising, because you can reduce these structures by applying a high voltage pulse of plus or minus 590 volts on an X-ray film in an opaque package. So that's one way of doing it. Corona stream discharge. Okay, so corona. This is very, very important to the technology that I will be discussing. That's relevant with the vibrations in the steam room, because a corona was used, a corona discharge was used in that technology. But of course, the corona stream of discharge is what you get in a Tesla ball. Okay, so a Tesla ball, in theory, if it's at the right energy levels, should produce a quanta of these strange radiation. Okay, and these two generated type of generators, I don't know what they. And essentially, he says with his device, he calculated that 1 hour exposure would damage red blood cells from the number of grays produced, and it would basically red blood cell damage and damage to the genetic material in white blood cells. And so essentially, he's saying that 1 hour exposure to his cavitator would kill a man. And this, Leclerc and his partner, with their cavitation device that produced every element in the periodic table, they also observed strange radiation tracks away from their device, and they almost killed themselves in a 1 or 2 hour experiment. Okay, so be careful when you're doing these experiments. Weird effects can occur around anti-gravity craft, as well as technology that relies on these phenomena. Things like time distortion, anything that uses a transistor will cease to work very effectively if you get within the event horizon, or within this sort of kind of boundary around the event horizon. You need to be careful with that. Now, there's a note at the end here.
Jerzy Bazatov, who sadly departed, probably because he was exposed to this radiation for too much time, he says that there is a way to protect yourself with a fluoroplastic plate. So, for instance, PTFE or boron. And the thickness of the sheet of glass must be 2 centimeters thick. And other authors like Shoulders and Shishkin are suggesting thin layers of conductor and insulator, saying metallized mylar sheet. I build them out of aluminium and cellophane, alternate layers, and so on. Boron obviously is a neutron absorber, so if you've got something with 5,000 to 7,000 neutrons, it's probably good to have that there. And fluoroplastic, I believe that fluorine is a good fuel for this, and so it causes a bit of a disruption to the things as they're flying through the air, and so that's the way that it interacts with that. Okay, so this is the point that I want to add in here from Shishkin. Now we've been talking about him, that he said in a private conversation to me in 2018. He says, after a while, my cavitator stopped producing strange radiation. In order to get it to produce it again, I had to physically move it to a different part of the lab. After a while, my cavitator stopped producing strange radiation. In order to get it to produce it again, I had to physically move it to a different part of the lab. So, what we know from the work of S.V. Adamenko is we've got something that's locked into the metal. We know from Shoulders that these things can stay in metal indefinitely. We know from, and I've shared this in many presentations, we know from Matsumoto, these structures grew on crystal boundaries and the ate spherical sections out of the material. This is by John Hutchison as early as 1979. Spherical sections inside a piece of metal were consumed. Okay, and we have observed this in our own Vega experiments last year and shared this widely. And we can see the whole process occurring on the macro scale. We showed how it grows in the crystal boundaries and it eats out these sections, does the transmutation, and so forth. And so this is very, very repeatable. But what we have shown in many of our Vega experiments, what Matsumoto showed in 1990 in his paper on his palladium deuterated rods, the material that's eaten in those, and other authors, is that it eats up to an area and it completely stops. Like nothing gets eaten beyond it. It's like a perfect boundary. And we've actually created things in Henk's work where we've got a structure that's 10 millimeters across and it's completely cut copper. It's completely cut copper. Now, if it was a thermal effect, the copper would melt and so on, because it's a very, very conductive, thermally conductive metal. But the fact you have a coherent matter structure, and on the boundary layer it eats everything, and then outside the boundary layer it does nothing. This is what I'm talking about. And so if you can imagine that you are producing this clusters in the aluminium in that structure, if we go back to it, so for instance here, we go back here. This is producing an area around it where this flux of relic neutrinos from the cosmos is being sucked in and aggregated into these structures. And Shishkin says, in fact, if I go back to his presentation, I missed that, so let me just go back to his presentation because there's one point we missed here. A string vortex soliton is an ordered vortex structure of cold neutrinos, since the interaction of string vortex soliton with radioactive isotopes changes the decay characteristics of these isotopes. Okay, so cold neutrinos are the technological equivalent of relic neutrinos, or they could be relic neutrinos. So let's go back to our slide here. So he's saying that this device produces this emission of these string vortex solitons, these neutral black EVOs in the parlance of Ken Shoulders, and that they go into X-ray film. But if he runs it in the same place too long, it stops working. And this was observed by Alexander Parkhomov as well. And so he literally has to get this device and move it physically to another part of his lab and turn it on again for it to start producing the strange radiation on the X-ray film. Okay, so this is consistent with the three-body alignment effects, where you get a sideways pressure because these things are partially reflected and refracted by solid bodies, and they're gravitationally lensed. They interact with neutrinos with gravity and the weak force, and therefore by proxy with the electrons. And so as it rains down, for instance, you've got like Betelgeuse shooting out a load of these relic neutrino flux towards, or lensing it towards the sun, and then the sun is lensing that as a lens module towards the moon, and then it's wrapping around the moon. There is stuff coming down which is of a higher density around the outside of the moon, and then on the inside it's getting shadowed. And all life uses this, all random processes use this, all matter use this, okay? And so you've got a higher amount on the outside, and it's pressure gravity. You've got pushing in from the outside, and that's why your Morris Elias in 1954 on the NASA website has a Foucault pendulum that moves out of sync when it's in three-body alignment, and that's why you have this sideways movement on the plane by Xu Wenju. And so you can have, this is the thing about a coherent condensate structure, is you can have two bosons or composite bosons occupying the same space-time, and that is a Bose-Einstein condensate. But you can also have Googleplex, okay? You can have a Googleplex, and they're still part of the same condensate, okay? They're still acting as one coherent body. But in some places, it's more, and it actually occurs with the Earth and the Sun, because these structures are gravitationally lensed, and you get a neutrino sphere around the Sun, and you get a neutrino sphere around the Earth, okay, where it's denser. And the reason things germinate in certain parts of the month, the reason why seeds like to germinate in the spring is because nature knows that we are the side of the Earth that's in its spring is going into a denser flux of relic neutrinos. The same condensate, but there's a denser flux, and all life is using it to transmute elements to do work within it. Okay, and this is some of the work from Simon Schnoll. And so we know we can absorb this stuff. And so if we're shielding it with the moon, we get a sideways movement. And if we're capturing it by having a spinning body, which can include a re-entrant jet from a cavitating bubble, you are going to be aggregating these things from the environment. There's going to be a lower amount of them inside here, and there's going to be a higher amount of them outside, and you're going to get diffusion from the outside to the inside. Now, these things don't see normal matter like you or I. They don't see things like normal gases do. So when you have a vacuum vessel, there's always these things moving in and out, like it doesn't care how good your vacuum is, it's going in and out. Now, if you have an electrical discharge in a vacuum, and maybe a magnetic pinch, pulsed pinch on there, like the Varchayev devices, it's going to be condensing these structures, these relic neutrinos, in there, okay? And then there's going to be a depletion in the environment around it, and therefore, after a period of time, there won't be sufficient to produce these relic condensates, these key structures for forming the exotic vacuum objects, for forming the ectons, for forming all these different names that different authors have given exactly the same thing, because they do, because they think they've discovered it first. And so this, for me, here is probably the most important comment I've got today, but it's definitely not the last. You may or may not be happy to hear that, because we're going to get on to the actual point. This is the background. So I want to say it again. After a while, my cavitator stopped producing strange radiation. In order to get it to produce it again, I had to physically move it to a different part of the lab. Okay, and this can explain why certain people's low energy nuclear reaction experiments don't work in certain parts of the Earth, even in the same time of year, or sometimes only work in the spring, or sometimes only work in phases of the moon, because there is a different flux of relic neutrinos, and the parameter space in their particular experiment might not be flexible enough to continue working with a lower flux. They might need a higher flux to initiate, because you have to get these clusters to a certain strength before you can get that electronuclear collapse. That is why you want to be technologically producing these, and that's the whole book with. That's the whole point about relativistic discharges, disruptive discharges like Tesla used the disruptive discharge generator. Cavitation is incredibly intense energy, highly localized, and so you get these incredible temperatures. Anything over 1,000 degrees, matter colliding together will synthesize cold relic neutrinos and antineutrinos that can start clustering to form these processes. So cavitation is almost the fastest way to do this. Okay, so I'm now coming to the work of Suhas Ralkar. He was trying to mill off-the-shelf particles to produce an energy generator, and he was trying to get them down to a target size of 5 microns. After milling process, he would desiccate these and grade them to 5 microns or less. The resulting particles would be placed into reactor cores, and then he used greater than 1 megahertz vibration of these particles in corona discharge. Remember what I said about corona discharge? We've got vibration here, we've got corona discharge, we've got something that was cavitating, and we've got metal particles. Note what he said here. In his reactor, if he didn't corona discharge but caused a spark, the core would blow up. It would blow up. So, cavitation of metal in water, this makes the charges, the magnetic charges, via cavitation and resonant modes. What am I talking about, resonant modes? Well, I think probably the best way to talk about that is cymatics. I don't really need to go into cymatics. You all know what I'm talking about, okay? And so it almost doesn't matter what your structure of your plate is. It will set up some resonant modes. Now, these things, this is a key point. So let's look at this structure here. These things like to live on a surface. So they like to form in surface boundaries. But if you add sound, then, for instance, if you've got iron or you have aluminium, for instance, you want to make an anti-gravity device using aluminium plates, okay, and you're using discharges, which produces static electricity, which gives you a lot of charge separation, and then you're spinning those plates, which are going to allow you to get towards producing these clusters. And then you are vibrating it. What you're doing is these magnetic monopole, pseudo-monopole structures that are bound to the paramagnetic aluminium are bounced, and they're bounced. And they form on the antinodes where there's no bouncing going on. Now, we've done this every day of the week in a $35 experiment. You can go and find out how to do. A 5-year-old can do it, and it's called Ultra. You use a ultrasonic domestic cleaner for you can get it off Amazon, have it delivered in a couple of days, and you can transmute elements using aluminium and water and sound. Okay, you get the cavitation, you get the charge separation, and you get the resonant modes. And the resonant modes appear almost instantaneously. We've caught it all on camera, and it's all shared, and you synthesize elements. And it's because you get this, in my view, these charge clusters forming, and you get the charge separation, the intense energy localization, the resonant energy localization at the nodes and antinodes, and you then get this aggregation, and you get these intense magnetic vortices and soliton pairs, Falasko-soliton structures. And this is what is going on. And you have an aluminium plate, and you're spinning it, and then you have magnets on there. The magnets will do this. They will create vortex pairs. They will create induction effects. And the vortex pairs, because the relic neutrinos have a magnetic component to them, they will condense in these structures. And so you've got the sound creating an assistance to the self-organization, and you have the magnet also helping with the self-organization, because in the aluminium, it's forming these eddy currents. The eddy currents have a vortical center, so you have another means of aggregating these around the edge. And this produces a cluster that gets bigger and bigger and bigger. You cannot see it. You cannot see it because it's moving material in the ether. It's moving material in the ether. And so this produces a large torus, probably 2 tori, depending on what you're doing. And this will produce a gravity shielding effect. It's preventing the action of gravity on the structure that's inside this structure. But things that you approach these kind of things with will not work. Things like phones, watches, any kind of electronics, because they use the Josephson effect, they use tunneling for transistors to work. This will not work. So electronics will not work around the technology that drives UFOs, okay? And it also messes with consciousness, because our consciousness works with this technology as well, okay? So you will have difficulty having a normal train of thought, and your perception of time will be completely distorted, because this is what causes time. Every random changing processes, the progression of time is counted in the change in the environment around you. If you don't have a change in the environment around you, time didn't happen. So if you remove the thing that causes time, then you can't perceive time. And if you remove the thing through which consciousness and connection to reality can work, then you will not have the ability to think in the same normal way that you do. Okay, so anyway, that was a little aside, but I'm talking about cymatics. I do need to go into it. There's many different patterns you get, so it almost does not matter which sounds you put in. But what I will say is, if you have higher frequency sound, you have more nodes and antinodes. Okay, so you can even it out. Okay, so let's go back to here. So makes the charges via cavitation and resonant nodes. That's the resonant nodes I'm talking about. Aggregates via resonant nodes. So I'm talking about the fact that you have these magnetic structures. They are able to move to the area of least movement, which is the antinodes in your cymatics. And it stores aggregate particles. So once you've got them to a certain cluster size, they become attracted to anything paramagnetic. So in terms of gas, oxygen is incredibly paramagnetic. It's bizarrely paramagnetic compared to all of the elements, all the way up to something like of the paramagnetic element. And so this is why you've got those weird glows above Chernobyl, because it changes the spectral bands, just as Xu and Zhu observed during 3-body alignments, because he has a different density of the relic neutrino condensates. Okay, so stores the aggregates in metals, and we know we can store it in metals because you've seen it in S.V. Adamenko's work right there, and we know that Ken Shoulders says it can stay in metals indefinitely, and this is what was going on in Suhas Raukar's reactor. Okay, so he then had a foil maker, and this was a fast. He only did this to produce a fast way to make nickel foil for part of the electrode, and he pulsed water flow electrical discharge with 19.46 kilohertz sound, and this would have assisted the formation and aggregation of these structures. Plasmoids were found in, and what I've got here is another slide down here, and this is the work of Bogdanovich, and this is a black torus. This black torus here, this is so good at grabbing the light, so the EVOs can be spheres or tori. Okay, this is a tori, so the event horizon on this is real time. This is a plasma flow discharge by Bogdanovich at the Moscow National Nuclear Physics Laboratory. So he has water flowing down here onto a metal plate, and he is discharging high voltage through here, and it's producing this plasmoid, which is you've got a plasma glow behind it, but it's not being able to get through the torus. So this is an example of this going on, and actually Suhas did this. And here is the thing that produces his, where are we? I do. There we go. So he has a plate in here. And he has got water, and the metal plate collects nickel, and it produces this nickel foil, which actually uses ultrasonics to delaminate as well. And this goes into the reactor. So let me just find, oh dear. The fuel is processed in this. This is PZT, and these are 1.5 kilowatt horns. So you've got 4.5 kilowatts of sound, and it goes into this. All he was doing is he was trying to mill the powders to make them. So he's taking off-the-shelf powders that are not at 5 microns because they're expensive and they're not easy to get in India. But you can get powders of different scales, and the idea was to just mill them and put them in here with a sealed thing. And then he had a cooling channel, and this outer chamber here was for cooling, because there's a lot of it. You've got 4.5 kilowatts of energy going in here. So he was only trying to make it smaller. And the funny thing was, is when we looked at it under the SEM, in almost every case, there were transmutation of elements. So this is the powder that's not processed, and not fully processed, because he's not graded out the different scales. And we found different elements being synthesized in there, like niobium and zirconium that weren't in the original material, and a lot of lead, 57% lead, 14% lead here, 51% lead. So why lead? Because it's the heaviest stable element in the periodic table. So if you're doing this nuclear collapse and you're building and building and building elements, you get to lead, and if you go beyond lead, it doesn't like to create radioactive elements, so it comes back to lead. So you end up building more lead, and if you pushed it harder, you would start to produce things that were unpleasant. You don't want them. That's what Adamenko did, and that's what Leclerc did. Okay, and here we've got what have we got? Again, more lead. Niobium. So those are the sort of things that he was producing. On the foil, we were getting things like gold, 31% in this little band area here. This is where the plasmoid came in and collided with the metal. And so we've got gold here and palladium here. And so we observed gold in the first couple of slides with the work of Adamenko, and here we've got it being produced in a nickel system. And we have these other elements, but also it produced this structure, which is in my view, with lots of other data that we've had since, this is a collapsed coherent traveling matter wave. And you can see the torus here, you can see the colloidal, you've got a toroidal motion here, and you've got a colloidal motion here. So this is one part of the overall structure here. And this was by weight, 94 of silver in this reactor. So this is one particular coherent matter traveling wave. Okay, so this is synthesizing elements. Now, what was he doing? This is the actual reactor to maybe give you a better idea of what's going on. It's going to do it. So you've got the metal going backwards and forwards. This is vibrated with your he has a discharge of 200 volts, and it was at 300 kilohertz. Okay, so not only was he doing plasma flow discharge like the Moscow Nuclear Physics Laboratory, producing those large plasmoids, he was also using ultrasonics. Okay, and then this foil and the powder goes into his reactor tubes here. So the foil gets scrunched up into a ball. It's a very simple construction. Scrunched up into a ball, you have your powder here, and you have an ultrasonic horn, which is actually at 1 megahertz. It's the thoriated electrode here. That's why do you have thorium? Because it lowers the work function. That is the ability for the electrode to emit electrons. And it penetrates, so the tip just comes through the nickel foil. So the nickel foil actually here is just to provide a conductor, a large size conductor, to allow for corona discharge. And is an initiator. Now, if it gets a spark between here and here, then this ceramic tube blows up. Why? Well, I've already discussed this in many presentations, but when you have the material condensed into the electron condensate, all the electrons, let's say there are 10 to the 23 electrons in a particular structure, which is much smaller than they would ordinarily be. Then you blow this with a discharge, coherent electrons then return to their normal electron charge. So you've got, let's say, 10 trillion electrons, right? But they're all acting with 1 minus charge. Okay, you disrupt it with an electrical discharge, and it blows up. And at the point that it starts to dishevel, all of the individual electrons become a -1 charge, and then you have a Coulombic repulsion between all of them, and it's incredibly violent. And Ken Shoulders talked about how, sadly, this can make unbelievable weapons. He said about a 1 cc of fluidized electrons would do a 10 by 10 by 10 meter volume, and basically everyone would be completely destroyed. So the point about what's going on in here is his metal is completely loaded with these monopole structures. And what do you want to feed it? Well, you've got a hydrogen atmosphere. Let's have a look at the overall reactor here. You've got 8 of these cores around the central tube. You've got a helical water around the outside, and it comes through the center, and it comes out at, let's say, 95 degrees C. We wanted to test this. We didn't want any phase change, okay? And so you have these multiple cores, and then this whole thing is in a hydrogen atmosphere. So it doesn't matter that you haven't sealed these things very well. It's not important. Because you want the hydrogen in there as part of the fuel. On here, a little bit more information. So this is the generator working, and it's producing steam there. It's wet steam, so there's a problem with that. And is this where he gives me some fuel? No. You can go have a look at this. This is on cmet.com and MFMP, and I describe in detail, but I have here the ultrasonic horn that connects to the reactor core. So it's a very simple construction. You have a ceramic tube here. You can imagine you've got your, have I got the diagram here? No, I haven't got the diagram here. You've got the nickel foil through this tube. You have the welding electrode, and in here you have that processed powder. Inside that powder, it is completely loaded, chock full of these magnetic monopole structures, these exotic vacuum objects found in the metal, like you saw at the beginning of the presentation in S.V. Adamenko's work. How do we know this? Well, because he gave us some fuel. He gave us looking at this in various different ways. This was on this polymer that's on the outside. So I had a magnet here. We know these things can be affected by magnets. So I had a magnet here, a little neodymium magnet, and neodymium magnet here. We had some neutron bubble detectors here. And this was left for a number of weeks. And we had these, whatever's coming out of this fuel, this is not graded and not sifted. So he didn't know that this had strange radiation emitting from it. We just discovered it by getting some fuel, and it came out and it was drawn into the direction of this magnet over here, and we've got this structure on here, and when we looked at it under an Olympus scanning laser microscope, we see the telltale signs of the impact of strange radiation. There's one track here, and these kind of double pits and group pits of the kind of appropriate scale. One of the reasons I thought to use a magnet in that way was the work of Keith Fredericks, who created these spots and observed these tracks. This is from Matsumoto, this star formation, and this is a similar torus that's rolling along the surface, flipping over end to end, same as you got here in Matsumoto's work. And he actually used a nuclear emulsion like Matsumoto, and because Ken Shoulders said that these things can be emitted from your fingertips, that's the easiest way to produce EVOs, he puts his fingertips, so if you ever think of going producing sound and sitting in the locus position, creating a vortical structure around yourself from the EVOs that are being emitted from your fingers, then people do that. I always used to think these people are utterly bonkers, but now I know they're not. Find a picture on your wall there, Tim. So you're emitting these EVOs from your fingers, and you've got left hand, right hand, which is exactly what you need to produce the vortical structure around you. So you put his fingers on this film and use this neodymium magnet and produce these different traces. So This is interacting with biology all of the time. Okay, so here is this thing here. Now, I have, so I'm just going to step away to talk about the fall off of these structures. And I've shared this slide with you before, but what we've got going on here is we have two brass plates. This is the cathode, this is the anode. This is caused on which leads to coherence of electrons. That leads to coherent matter. Okay? You then have the coherent matter, the macro ball lightning forming here. When it disrupts and explodes, we have the emission of part of the original structure of the coherent matter structure in the form of a coherent matter traveling wave. And here, if I press play, you can see it flying out of there. Maybe you can see that. So it goes boom. Recently, using computer animation software, I've simulated how this works with toroids and so forth. So we've observed all forms of strange radiation track in 3 dimensions using this type of approach. And here is a undiscussed strange radiation track interacting with aluminium in work from 1990s. This is a dual EVO. When I say dual, it's like a condensate of possible, and I'll talk about this in a separate presentation. It's possibly a singlet electron condensate where you have spin up, spin down, but like a massive singlet state. Or it's a positron electron structure in a massive coherent iconic cluster structure in the form of a thing that's much larger than a normal positronium. They can spread apart and they come back together just like a phallico-soliton does in a swimming pool. But down in this bottom side part here, you have this type of strange radiation track where the helical structure of the coherent matter traveling wave is traveling through. And because the binding energy of the electrons and the ions in this coherent matter traveling wave structure is far higher than normal ordinary matter, normal ordinary matter has no way of being able to resist this. And this is why it makes unbelievably unpleasant weapons. This is why the Hutchison effect did really weird stuff, because ordinary matter cannot deal with this. Okay, so this is what I'm talking about. This structure here has a very defined boundary, and when it goes through this aluminium, which is a highly thermally conductive metal, it's literally cutting it exactly the same shape as the coherent matter traveling wave. Okay, it's not spending long in here, but it's completely removing the material. This is what I'm talking about with an event horizon. Outside of it, it's largely unaffected. Inside of it, it's completely changed. Now, in this particular video, which I've analyzed in detail, this is about 5 frames within, and you can see several coherent matter traveling wave structures going around. This one here is beautiful because you've got the positive and negative structure orbiting around each other. But we've got one that comes up here. It orbits around this one before it even gets there, and it comes over here, and this one comes up here, and it's orbiting around here. This one comes around and bends around, and then this orbits in the other direction. But they're not really interested in where the anode and the cathode are. They're only interested if they come within a certain distance of each other. They literally they go in exactly the direction they want to go in until they look ahead or look behind the structure of another one of these coherent matter traveling waves, in which case they move very intensely. And one presentation where this is very clear, maybe not so clear, but you'll have the slides, is this one, which is of frames where we've got a large plasmoid structure in a reactor. This one that comes out, it comes out here, it goes over to the left, it bounces off the cathode, it gets re-energized, comes round to the right now, comes round to the right, comes round to the right, and then another one is blowing out of the birthing zone over here, and it comes in, and it's doing its own trajectory, and then in one frame, 1/60th of a second frame, it starts to come orbiting around the that's just come round from the side. So it has no influence. It has no influence on the influence in the world. And then you see another one here in purple coming out. It's moving in its own direction. And then it starts to interact with the two that are now nearly perfectly in sync. They're self-cohering. They are self-organizing, coherent matter traveling waves. Okay? And there's no resonant chamber in here. They're just doing it because they're so influential on each other. And this one comes in and it starts to wrap around this one. And it's wrap around, and then these three come together. But for whatever reason, these two may have performed a decent, stable structure. But by the time it gets to here, this one has disrupted them, and they kind of wobble out, and they go on their own merry way. But another one down here bounces off the bottom, and then it comes up, and it's hilarious. It comes to here, and then it orbits 180 degrees only around this one's path, and then it starts to follow it. So the influence on each other is phenomenal. The ability and desire for them to collect and organize, but they're organizing at a distance. And this is what Ken Shoulders observed. They form bead chains. Matsumoto observed this as well. We have observed this. Many authors have observed this. And in fact, even if you go back to the original work that was a reference for Ken Shoulders, this is the Lafferty book here. There is a book in this, a page in this book where they actually characterized where cathode spots produce these structures. And this is probably way back in the 60s or 70s. And they produce these parameterized grouping. So you have one on its own, and then you have two that are orbiting, three which are equidistant, 120 degrees, and so forth. And so you can imagine that's like a collision of one of these self-organized structures with the surface, but within them they have their own substructure, which I've discussed in other presentations. Okay, so why am I talking about this? It's about this aggregation process. And just for some fine detail, this is from Zhigalov, Vladislav Zhigalov, and he looked at one of these birdies that he produced in a laser, using a laser, which was suggested by Lowe in 1973 as a way to cohere matter. You actually use coherent light to cohere other matter. This was suggested in 1973. He used laser into water that had been exposed to sunlight with, or being outside, with 0.4 Tesla magnets underneath it for about 10 days. This actually allows the relic neutrinos to, in my view, aggregate into the oxygen that's dissolved in the water. So the oxygen's paramagnetic. The cooler oxygen is, the more paramagnetic it is. That's why if you have liquid oxygen, it stays between the two magnets, okay? So the cooler it is, the much more paramagnetic it is. But let's say it's just paramagnetic in the water. You've got the relic neutrinos coming down, and you've got the magnets underneath. Now, here's the thing. If ancient people took a magnetite bowl and they put water in it and they put it into the sunshine, that water would be very, very materially different after a period of time, because the oxygen dissolved in the water would be replete with clusters of magnetic monopoles. All water is not the same. It's absolutely not the same. Cavitation running down a stream, crashing against a shore, working its way through cracks from underground, whether it's volcanic or pressure related through rainfall and so forth and springs. Any cavitation was synthesized through cavitation, through this process, fresh, bioavailable dust. This is why it likes to live near streams, likes to live near the sea. It doesn't like to drink someone else's water, ideally, because biology will absorb this stuff. But water exposed to the sun in a petri dish, in a sealed vial, and then exposed to a laser, produces these structures on film. And when you look at the outside of these structures, and I believe these are also similar to the macro structure. This is an aggregate of aggregates of aggregates of aggregates of aggregates of aggregates of aggregates. Okay, and these things can scale. And the pseudo-north monopoles like to join the pseudo-north monopoles, and the pseudo-south monopoles like to join the pseudo-south monopoles. What do I mean by that? If you can imagine this is a mushroom, okay, this is like a primer fields bowl, or more specifically, like the Boyd-Bushman directional magnetic beam pattern by Lockheed Martin, which when he was working at Lockheed Martin, and it produces a magnetic beam of either south or north energy depending on the arrangement of the magnets around the other 5 sides of a cube in the basic configuration. But this is more like a primer fields bowl where you've got lots of magnetic monopole structures or things that have a magnetic beam pointing into it. This intense magnetic beam here, in my view, is the disruption beam in the Podolsky work, which causes material to blend into other materials in the same fashion as the John Hodgson work. So, like I say, spinning bodies will produce these things. Electrical discharge will produce these things. Cavitation will produce these things. Okay, so lastly, I have my steam. So this is a steam in my city here in BurnEye, and I'm going to use a phrase here as I drink my fake Soviet cola here, because they didn't get Coca-Cola over here, so they invented this thing called Cola. Do you bring Muhammad to the mountain or the mountain to Muhammad? In the case of S.V. Adamenko, he was bringing the Muhammad to the mountain. He was taking the thing that needed to be cohered and transformed to the mountain, which was in the accretion plate in his experiments. Okay, that's not going anywhere. It's stuck there in the landscape of the accretion plate, and he's shooting the ions into it. It's kind of like the realization I had was, what is so important in Suhas Ralkar's technology that he has to have this ultrasonics here, moving these particles around, okay? And then you've got a corona discharge, okay? Well, what is a corona discharge? Well, you've got ions and electrons forming, okay? What did I say these structures need? They need ions and electrons. This is exactly, with all certainty, you can possibly imagine, by the claim of S.V. Adamenko in that accretion disk. They feed on ions and electrons. Okay, Shoulders said, what do you do to keep an exotic vacuum object alive? You feed it electrons. Okay, all right. And if you don't feed it enough electrons, they die. But they will reside indefinitely in metals. He has metal powders in here with absolutely replete structures. We saw it shredding polymer, and we caught them on a web camera, the one that I'm looking to you on now. In fact, I can show you that. We're nearly at the end, you'll probably be pleased to know, in a different thing. So this is a side view. So you've got the ultrasonic horns and the reactors here, the water on the outside, the water on the inside. To do the strange radiation analysis. Give me just a second. Nearly there, honest. Maybe it's way up. Okay, so this is what his fuel did to a plastic container after just a few days. It's just, well, I don't know why, but I put my unprocessed fuel into a container and it shreds them to pieces. And he literally lifted this one that was on the shelf behind him off the shelf, and as he moved it around, the whole thing just fell apart. It wasn't in this state when he started to hand it to me. It was quite funny. So then I decided that I thought, well, okay, maybe that's producing some strange radiation, so maybe we should look at it. And so you can see this macro photography. So these are the stars of Matsumoto, and what these are showing, and you've got the helical, sorry, the toroid running over each other. It produces like these like train tracks. And here's a star, and the the structures coming up. This is a blowing up macrocluster that's here, blowing up macrocluster here, and it shreds these two lines side by side. It's literally shredding the polymer. There's some closer, different macro. Here's some nice shots here. There's the train tracks here. So you can go and have a look at this. So this is this little container here. It was so destructive, and the energy in these things. And I don't know. I think S.V. Adamenko found these were large numbers of giga electron volts, each one of these structures. So I then used Cosmic Ray Finder, and I put PTFE here. This was because it was just something to cut out the light. And little did I know, and later find out, that fluorine and carbon are good fuel for strange radiation, i.e. exotic vacuum objects in dark mode. And so you had them coming out here. They were excited by this PTFE tape, and they came into the structure, and I think we have a number of traces there, but they're not the best, so we'll go to the next one, which is up here. I changed the orientation so it had a longer run through it, and it shifted over time to here. And this is my favorite trace. And the reason this is my favorite trace, because it exactly lines up with one that was found in the first Lion that we looked at, the first Lion reactor, the actual geometry of the trace. And this shows the structure of where it's moving. And so this was determined from the pixel size on the detector. And so this is not three-body interactions. This is not a piece of grit between two things making a trace as it rolls around. This is something that came out of that reactor, out of that fuel, after an exotic vacuum object destabilized and blew up, a macro cluster. And a fragment came out. It went through the polymer, it went through the air, it went through another piece of polymer, it went through the air, it went through many layers of PTFE, it went through the plastic on the front, through the IR filter, and through the lens, and into the CD, leaving this track. It's incredibly energetic, and it must be neutral. And this is it overlaid onto the Lion track here at same scale. And I actually, interestingly, I didn't have to rotate the actual track. So you've got the monopole structures here, but you've actually got the excitation of the CCD. Okay, so why am I? So we know 100% that it was emitting strange radiation. In fact, we observed it on X-rays and so forth. But I think observing it using a CCD is probably the most interesting of the findings. So back to our thing here. So why was he using ultrasonics? Or why did it work? Well, it's a case of he needs to feed these things with as much of ions and electrons as possible. And in the reactor, he has absolute buckets of ions and electrons because he has this corona discharge here. Okay? But what we have shown is that there is this incredible event horizon where everything happens when you cross the event horizon. Everything happens when you cross the event horizon. Everything happens when you cross the event horizon. Everything happens when you are crossing an event horizon. And then shooting ions into the center, by having this vibrate, you are moving the particles, which are all over the surface, covered with these, what look like, if you were to be able to see them, they look like solar prominences. You have one pole and another pole, and you have material that's sweeping through in an intense magnetic flux loop. Okay? And that magnetic flux will grow and produce energy by fusing or fissioning them appropriately to or from heavy elements to light elements, or from light elements to middle of the road elements, somewhere between iron and calcium they tend to end up. And so I was sitting in this steam room about four years ago, and I sat there, and when you're sitting in the steam room, you're getting hot, and you're getting hot over a period of time, and that's called Brownian motion. So that's like our particles sitting at the bottom of an echo reactor, not moving. Okay, they're only getting the electrons and the ions that are getting there by statistical chance of particle interactions through Brownian motion. And going on in the Adam experiment, even less is occurring. But if then vibrate my hand, as I did a couple of years ago, like that, what you find is, and you can go and experiment with this yourself to have a very visceral connection with what's going on, your hand gets a lot hotter because all these water molecules in the air that had a lot higher energy than the temperature of your hand collide with your hand, they share energy. What that taught me is I am adding more of these molecules to my hand. And this is what's happening. It's like wind chill factor. It is like being on a motorbike with a helmet off and going on an icy road. If you stand on the motorbike, you're pretty okay. You've got hairs on your face and stuff, right? You're not so cold. But if you get on the motorbike and you go at 70 miles an hour, believe me, your face starts to freeze pretty darn quickly, okay? This is what's going on in the reactor. You need to make these structures. And in conclusion, I'm just gonna kill my presentation here. Okay, so can you see my mugshot, my ugly mugshot?
Yeah, and I still have you spotlighted too. So
okay, fine. Okay, so you need to make these structures like on this Hutchison sample here. You will have the structures growing on the grain boundaries, as referenced last year, and we can observe it on Hutchison sample, and they build up on the and only all these grain boundaries. In iron, to get them to build up inside the material, they will produce intense magnetic poles because they lock. In aluminium, they can move around and jiggle, so you'll get one moving, grow here, and another one growing here, but if they're too big enough, and if they're the same pole, they'll come together, so they can go. Right? But iron, okay. So as you get this building and you're building, they stay locked in place, and they're locked so hard to the iron that new ones that are formed jump onto each other, so you get an aggregation of norths and souths, bigger and bigger and bigger and bigger, until if you have two norths that are growing and growing and growing, they will then literally tear the sample apart. It literally goes because you have an intense north and an intense north, so you end up with a sample that has two norths. Okay. Now, when George was talking about all of these different systems producing the same effect, and probably it was John having some interaction with it. There's two things that he's saying which are correct. Yes, if you're electrically static, sensitive, right? Some people do that, some people can't, right? There's a certain level of field we can sense. And you will know better when it's going to occur. But he also used an AM radio. And in the previous presentation, I showed you that when you get an electron macrocluster disheveled, and the electrons that were formerly in a condensate state blow up, they then return to the state of normal electrons. They form a caloric repulsion, which is instantaneous, and that produces a scalar wave. That gets picked up on AM waves as broadband AM and gets in the pop. So he used two tricks. He used the fact that he's sensitive to electrostatics, and he used the fact that he's listening for those pops. And it doesn't happen immediately. You have to have patience, because if you haven't got things set up, you will not get the clusters forming very quickly. If you haven't got the parameters right, they will not form quickly. He had a high intensity discharge xenon tube. That is absolutely perfect for producing loads and loads of these loads, and you guide them to the sample area. They aggregate in the sample area. But he also sometimes used traveling waveguides, and he also used sometimes some uranite. As I said, it was always in presence. Uranite by itself will be producing these things, right? And you need to aggregate them and guide them to the active area. Once they are there at a sufficient intensity, they will lock into place. With aluminium, they move around, like I said, on the ground, and they tend to stay in place and grow in situ, okay? And you could use sound, actually, to improve it, and I've talked about how you would use sound, and I talked about this before the Salvatore patents were released, that you would use a technique that was developed in the 1950s to use a piezo material to convert high frequency magnetron output, say 10 megagigacycles or whatever they call it, sorry, 10 gigahertz or whatever it's on, and you convert that into solitons of traveling waves, scalar waves, which are just actual phonons that are of the same distance as the interatomic spacing. And this is specifically said in New Scientist in 1963. This is not patentable, okay? Sorry, Salvatore Pao and the US Navy. This is not patentable. And what this does, it causes these structures, these electron condensates to grow in each other, as we have shown in Vega. They wet together, and that produces superconductivity through the structure. And this is specifically said in the book, which you can download off remoteview.icu by Takaaki Matsumoto. And he said this in 1999, okay? And he said the structures, and we have demonstrated it in a huge scale using the ball lightning here, and one ball lightning here, and one ball lightning here, and they are wetting their electron condensate north-south magnetic monopole structures, pseudo-monopole structures together, and when they are big enough, they wet together, and this is one condensate. This is one electron fluid condensate, okay? And I will be producing a book of that. That is actually a 5 millimeter by 7 millimeter demonstration of what self-organized plasma can create in other matter by and showing how the magnetic and nuclear transmutations and everything is aligning up. But anyway, my point being is that you can create superconductivity in the metals, and then once you get superconductivity, you have some very, very weird effects going on, like things become transparent. Okay, and I gave an example back in 2017. Maybe I can quickly find the presentation if I don't.
Yeah, and Bob, if I could jump in really quick. So we have 10 minutes left until David is on. We're going to have to skip the Q&A session for today, and that's totally cool. That's totally cool. I
don't mind taking questions. I just want to share this.
Oh yeah, no, I just want to let you know we have a hard stop in 10 minutes. So
okay, great. Okay, so let me just see if I got right one here. What they're talking about. No, I've lost my thread.
Yeah, I can't thank you enough for. I mean, you have run through so much material today. You know, this is a lot of food for thought. So, maybe if you're open to it, maybe we could postpone Q&A, because I know it's getting late your time, but.
Oh no, it's okay. I know. This is from an old presentation, but it's got some useful slides. So let me just switch back to show you my share. Okay. So I think I gave this presentation. So what are you seeing now? I don't know whether you're seeing. What are you seeing?
Yeah, so it's back on your browser and it's showing schema.
Good. Let's go here then. Right, let's find the slide I want to show you. So this is the bead chains by Shoulders. What I'm talking about is this famous experiment by Thunderfoot, where he mixes sodium and potassium in water. And so you have your silvery metallic thing. It becomes black as it interacts with the water, and then it becomes transparent. Now, I believe that this is because you have an electron condensate, or an intense amount of electrons that are interconnecting their wave functions in here, and it's interacting with light in a very materially different way. And then it explodes, and the explanation for the explosion is a Coulombic explosion, although this is an ionic Coulombic explosion rather than this pure electron Coulombic explosion. But this isn't exactly what I'm saying, but what I'm saying is that if you have this going on in the metals may actually become transparent. Okay, so if you had anti-gravity craft using this technology. A number of things. I talked about the fact that it's likely that they will have plasma, and the plasma will grow through several colors from sort of the ionization of nitrogen in the air and oxygen, and then it will go through to UV, so it'll blue shift. It'll go like purple through to yellow. This is my prediction off the top of my head. It would go to a UV blue type look, and then it will start to look transparent. And there's two reasons for that. One is when it's a coherent condensate, the light from behind will bend around the entire structure, like it does around a black hole. And the other thing is the actual metals in there, if they're depending on their metals, will become partially transparent. So you might even be able to see into the craft partially, because of the way that the technology works. This is the transparency thing. So let me go back to so I hope what I've given you food for thought is that when George Hathaway is saying he doesn't know, he has loads of different systems produced it. Over 9 years, Shishkin et al. in Dubna in Science City, 50 kilometers north of Moscow, found that very many systems produce these cleaner condensates, which can start off as electron condensates carrying ions, but they carry ions definitely, and when they interact with materials, they act as if they have neutrinos in them. Okay, they are neutral because they're coming through the water, they're coming through the aluminium, they're traveling over air, and they're going through the sheath of the radio plate, the emulsion, and they are interacting with the sort of silver compound on the impure emulsion. And so you can imagine how these things are clustering, and they can cluster and be produced by a range of things. The simplest way that you can do this and to do nuclear transmutation is to go and buy yourself an ultrasonic, probably around about 43 kilohertz domestic cleaner. They're about, I don't know, the size of a toaster, and they cost about $35. You can get aluminium kitchen foil and high quality or any water, but it's useful to have deionized water. You put it on the underside of a cake box from an old CD stack, and you sonicate it for about 3 minutes, and you find these yin-yang pairs, and in the center of the yin-yang pairs, where the forces are most intense, you get synthesis of elements, and you will see that you have coherent matter, frozen coherent matter traveling waves on other areas of the aluminium as well. It's the simplest way. There's a long history with people like Roger Stringham of synthesizing elements using ultrasonics. And the higher the frequency, the more resonant nodes you have. So Suhas-Rao kind of reactor was having 1 megahertz. So not only are the particles lofted into this ion and electron-rich food for the magnetic monopole flux loops, the organization in the whole system is much more superior as well. Okay, and so forth. So this is you in a strong wind, or this is you on a motorbike driving into the wind, or as I said, vibrations in a steam room.
Wonderful, sir. We have 4 minutes left. We have 4 minutes left. So yeah, I don't think we have time for questions. Actually, you know what? Let me do this, and maybe David Chester is with us, so maybe we can start him a couple of minutes early. But let me remove the spotlight there. And what I want to do is I want to put this on gallery mode, and everyone, please give a tremendous for Bob Greenyer. Bob, that may be our longest straight-through presentation to date. That was amazing. Thank goodness.
It would have been more organized if I'd had the other 3 hours I thought I was going to have. It would have been shorter.
I would always love to have you back. So, you know, if you have more to share, or if you want to come back and do a Q&A section or any